So welcome to this webinar, and I will introduce you to the FITMAN Collaborative Asset Management Specific Enabler, or in brief, FITMAN CAM. And my name is Mauro Isaja, and I work as a solution architect at engineering, which was the main driving force behind the development of this software. So let's start with a very basic introduction, and let's go through these bullet points one by one. So FITMAN CAM is an integrated platform for managing tangible and intangible assets in service-oriented manufacturing ecosystems. Now we'll see in a minute what tangible and intangible assets are in this scenario. But first, let's see what this scenario is. What does it mean, service-oriented manufacturing ecosystems? Well, I think that what a manufacturing ecosystem is clear enough to everyone. But in this context, the service orientation means that the ecosystem members cooperate by providing services to each other. So again, what kind of services are these will be more clear when we explain what assets are. For now, I just want to stress that this scenario, manufacturing ecosystem scenario, is just the main scenario for FITMAN CAM. I mean that several other scenarios may exist where FITMAN CAM may be useful in the scope of manufacturing, but even out of its scope. So I'm not going to discuss this now. You will see by yourself if FITMAN CAM fits your scenario or not. Just be aware that I'll be presenting what I will be presenting here is related to the main scenario. And the main scenario is about digital and virtual factories, which, as you might know, are domains defined by the factories of the future, which is where this software comes from originally, because it comes from a previous project which is called MSCE, and we will see this when I will do the live demo of the software. And the software is based on open standards like OL2, which stands for ontology web language, and linked USDL, which is universal service description language. It is delivered as a web portal, and it supports platform federation, which means that you can federate more than one instance of the software under the same single sign-on security context. What are the benefits of the software? So, and now this is where we start explaining what the virtual assets are, in fact. Well, assets are, in our context, any item of economic value which is owned by an enterprise. And they are basically resources and capabilities of the enterprise. Resources are tangible stuff like machinery, hardware, vehicles, buildings, even people, while capabilities are intangible stuff like knowledge of the corporate knowledge of the enterprise, like, for example, business processes, technical processes, and competences of the individual, and the business relationships, and anything which is an asset for the enterprise, but it's not tangible by its nature. Both tangible and intangible assets, of course, are used to achieve the goals of the enterprise. In particular, in the virtual factory scenario, where we have several companies which cooperate to the same goal, to the same business goal, assets are used in a collaborative way. So it is something that the different partners of the virtual factory are providing as a service. So they are exposing these assets, probably also trading them, meaning that these are commercial services within the ecosystem. And FITMAN CAM is a platform for the collaborative management of assets as a service. So these are entities which are typical of the virtual factory, but as we will see, assets by themselves are much more generic by nature, so they can be used even in very different scenarios. FITMAN CAM is targeted to the business users, not to the technical user. And this, as we will see, means that we have several limitations in this tool with respect to more ontology-oriented tools, but the easiness by which the user can deal with the ontology in this tool means that they really don't have to have a deep knowledge of ontology-related concepts. So let's have a brief walkthrough across the features of FITMAN CAM. By means of this tool, you can define a reference ontology to describe your assets, and this you will do using some constructs coming from OAuth2, like classes, individuals, and properties. And so with your reference ontology, you will describe your tangible and intangible assets, and you will store this description in an online repository, which is shared, of course, and as we will see, can also be accessed from the outside by means of an API. Then once you have created your assets, so once you have described your real-world assets in terms of classes and properties, then you can expose them as services by means of a universal service description language wrapper. So you attach a descriptor which defines the terms and conditions of use for your service within your ecosystem. And this means, of course, the availability, the pricing, and all this kind of stuff. You also can create asset bundles by composing several assets together in a single service. Then you publish these offerings on a service store, which means on a marketplace, which spans the manufacturing ecosystem. And from that point on, you can search, anyone can search for your offering on the marketplace, on the local marketplace and the local ecosystem, or across all the marketplaces of the federated ecosystem. From the technology point of view, as I mentioned, this is a web-based software. You don't have to install anything locally. A single instance of FITMAN CAM can support a very large organization because you can integrate several corporate user credential databases like LDAP and Active Directory without the need to replicate the user credentials within the FITMAN CAM platform. You simply integrate your existing databases in the platform federation. And of course, as I mentioned before, you can also create multiple instances of FITMAN CAM, so a distributed installation, all under the same single sign-on umbrella. So the single sign-on is, of course, where you control not only authentication but also access rights to your information. The low-level features are all based on the standard, the de facto standard open source components like the library portal, Sesame, which is an ontology repository, and MySQL, a relational database. And we also leverage some fireware generic enablers like the marketplace and the repository, which are an implementation by SAP, while the core functionality, which means the front end, has been developed internally by my company, Engineering SPA. So meaning the asset manager and the service manager portlets. And finally, we have not only a front end, a web-based front end, but also we have more than one layer of APIs for integrating external applications. We have a low-level API based on Sparkle. Every API here is REST-based, is RESTful. But the lowest level is you need to run Sparkle queries directly on the asset repository. So you can query the ontology and the tangible, intangible assets, and you can also you can not only read but also you can write. Then you have a mid-level API for interacting with services. This is a read-only API, so you can list all the services which are available locally in the service repository. And lastly, you have an high-level API which comes from the marketplace generic enabler. Now, we don't have a front end to the marketplace, I mean to the marketplace generic enabler which comes from fireware, because that is a headless component, and it is, let's say, the last step of the publishing of asset as a service items. Then once we have published our information to the marketplace, then it is up to someone else to extract this information from the marketplace. Finally, all this software can run on any Java-enabled system. So it's all server-side Java technology. This is a logical architecture overview, just to show how these concepts are layered vertically. So if you can see the pointer of my mouse, I hope so, then starting from the bottom, we have a base layer, the base ontology layer, where we have some base classes and base properties which are system defined, and you cannot change them, and this is the basic infrastructure that is used to define your custom classes on the upper layer. So the custom classes are user defined. Then on top of the custom classes, you have the custom properties, and you will have, as we will see in the live demo, asset models and asset instances. The asset models being templates from which you can instantiate concrete assets which are representing the real world assets of your company. Then on top of this, we have the asset as a service repository, and this is where you can compose several asset as a service into a composite asset as a service. Somehow my mouse pointer has disappeared. Oh, okay, here it is again. We have, as I mentioned before, these three layers of API. The lowest level, it is the virtualized asset repository API, where you deal directly with all two constructs. Then on top of this, you have the FITMAN CAM API, where you deal with services. And finally, you have the Marketplace API, which is dealing with the commercial offerings of the services. How it is distributed, FITMAN CAM. So we have three kinds of distributions. Well, we have two, currently we have two of them, and we will be adding a third one as soon as possible. Currently we have two flavors of virtual machine images, one for KVM systems and one for VirtualBox systems, so meaning that we are covering more or less every possible operating system. And you can also download the source code from SourceForge. These are the links, but of course you can ask me anytime a link to download this, and if you have any problems in running the software or building the source code, please don't hesitate to open a ticket on our support platform. Then we will have, as soon as possible, a third distribution channel. We will put a shared instance online on the cloud, so that you can play with it without the need to go through this complex setup. I'm not aware at the moment how much time it will take for us to have this shared instance online, but I hope it will take a couple of weeks at the most. Terms and conditions of use, well, this is open source software, so basically you can do whatever you want. Of course, we have a collaboration agreement with the FI-PPP program, so every software coming from the FITMAN project is free for use within the program, but this is anyway open source. It is licensed under the Apache 2.0, so it is also let's say commercial friendly license. It's not JPL. So I think that this might be enough for the presentation, and I will go immediately to the demo. And if you agree, I will leave the questions and answers at the very end of the presentation. This is, as I mentioned before, this is not exactly the FITMAN CAM software as you can download it from the links that I gave you 1 minute before. This is a running instance which was part of the MSEE project, which was an FP7 project of the Factories of the Futures. But I think it is a good example of how you can use the basic FITMAN CAM platform, which comes as a library portal, to expand, to expand its functionality. And in this case, we have an entire portal dedicated to manufacturing service ecosystems tools, and FITMAN CAM is just a little part of it, and it's under this menu entry here, SLM, which stands for Service Life Cycle Management. And here we have the two portlets that make the FITMAN CAM software, the asset repository and the assets as a service. Now, the asset repository is something that you can use by itself. So you don't need to create assets as a service if you don't need to. And this is the reason why we have actually two different portlets to manage this stuff. So let's start with the asset repository. This is where tangible and intangible assets are defined and are stored in the repository, which is also accessible, as I said, at the lowest level through a REST API and SPARQL queries. So assets are categorized by class, and classes themselves can be defined as a hierarchical tree. You can see this on the left side of the screen. What you see in this tree is an example taxonomy. So this is something that we have developed for a use case in the MSEE project, which dealt with a textile industry, cloud manufacturing of shirts, just to explain the context. But this is a simple taxonomy, so it's a hierarchy of classes. If we click on any of these classes, we navigate to a page where we see the individuals belonging to this class. And in this case, we see a list of cutting machinery, which belongs to the cutting class. And all these are supposed to be concrete cutting machines somewhere in the world. While if I click on the drilling class, I don't see anything because we don't have any drilling machines in the textile industry. Okay, so I don't know if you are familiar with ontology concept, but if you are, consider that this tool is a radical simplification. So it allows the users to express a very small subset of the whole tool language. And this is because this is not intended as an ontology editor. We rather exploit some basic all-tool functionality to provide the non-technical users with an easy tool so that they can describe real-world objects in terms of types, properties, and relationship without having to deal with the complexity of tools like, for example, Protégé, which is a de facto standard client to manage ontologies, which is very complex. Myself, I have problems using it. But anyway, the point is that while this is a very simplified interface, what you actually store in the repository are all two ontologies. So it is something that it is standard-based and you can share with others which are using different tools, like, for example, Protégé. So let's see how the typical user will work. For example, the typical user may want to create a new type inheriting from an existing one. So for example, we might want to create a subclass of deformation. So I right-click here and I type the unique name of this new class, which might be a pressing machine. So I have created a new class here, and this class has no individuals right now. So let's go back to an existing class with existing individuals to have a look at how individuals work. One word of caution here that we don't support, in this simplified version of the ontology editor, multiple inheritance. So you can only inherit, your classes can only inherit from one single class, which is not what happens in OL2, but it's more similar to what happens in an object-oriented programming language like Java. Also, we don't support properties that are defined at the class level. Properties are defined in asset models. Asset models is an abstraction that we have introduced in this tool to give a more flexible way of defining prototypes of assets without being too structured as you might be in an object-oriented programming language like Java. Let's see this in action. We have an asset model here, which is this one, this Bivolino cutting machine. Bivolino, by the way, is the company which was working with us in the MSc project, the textile company. So, for example, we look in detail at how this model is structured, and we see a list of properties here. And properties can be attributes or relationships. Okay, so what we see here is the default properties of this type of assets, so the Bivolino cutting machine. What does it mean? It means that if I want to create a new instance of the Bivolino cutting machine because I have a new cutting machine in my shop floor, all I have to do is to instantiate this model, assigning a unique name and possibly an owner. And then here it is. What I have is by now a copy of the model, but once I have this copy, I can change it whatever way I want. I can also add new properties or remove existing ones. And so I have an independent object which can have its own structure, which is independent from the model. In the sense that now I can even change the original model, and these changes will not be reflected at all to the individuals that are derived by this model. So this is quite different to what happens in a relational database. So this is more or less all regarding the asset repository. Then we have the service layer on top of this. The service layer is much simpler than this. And it is even simpler in FITMAN CAM because FITMAN CAM is a little different from this version of the software, which is quite old by now. We simplified even more because we realized that we had too much complexity, too much flexibility in the service definition layer. And so what we do have in FITMAN CAM as of today is the capability of creating services which are a collection of assets, and then we can attach a linked USDL-based description of this asset and publish it on the marketplace. And this is another important step that has been radically simplified from the original linked USDL technology, because linked USDL is simply an ontology-based, another ontology-based language to create documents which are, of course, in a standard format and can be machine readable. But what we need here is something which is user-friendly. So what we did is creating another templating engine by means of which the system administrator can create a linked USDL templates. He will register them with the system, and then to use the template, you will simply create a new instance of the template, and the system is able to parse the template and create dynamically a form with the fields that the end user has to fill in order to create the service definition of this service. So, for example, textile machinery. Textile machinery has a linked USDL template composed of these fields. I simply fill in some fields, and now it is just to simplify because I see that we are very late. So I fill in the form, and then when I publish this information, what I have is a linked USDL template which has been transformed into a linked USDL document, and this is published on the marketplace generic enabler as an asset as a service offering. Okay, so I think that we are over with the time, so it's better if we start with the questions and answer session. Any questions?
Yes, from Noam. You hear me?
Yes, I hear you, Noam. Hi.
Hi. Okay, I think what you just showed us is mainly, texts and tables and assets as, as text. As you know, I think you know what we are trying to do is that I need that behind each of these lines or assets will be a real intangible asset. I mean, CAD file or STL file. How do I integrate it into this system, if at all? You understand my question?
Let me understand exactly what you mean. So you mean that the intangible asset is a file, which is a CAD file.
Yes.
And you need to keep the link between the CAD file and the description of the CAD file in terms of intangible asset. Is this your question?
Very basically, yes. I mean, the CAD file is not only CAD file. I need a lot of information around it.
Okay.
And to link it to, exactly as you say, to machinery and 3D printers and technology and materials.
Yes,
but in
yes,
the
sure.
end, it's all related to one CAD file, which is the spare parts that we want to distribute.
Okay,
Is this something that we can handle with this platform?
Let's say to make this question more generic, that what you need is to keep the link to digital resources that are stored somewhere, okay?
Yes.
Okay, so my suggestion, because we don't have this support directly into the FITMAN CAM, but I think that you can easily use the same infrastructure, of course, with some additional effort from your side, from the programming side, because what you can do is that you define properties of the intangible assets, and these properties are actually URIs that point to some repository. The repository itself is included in the software because we are using the repository generic enabler from Fireware. And repository generic enabler is basically a binary object store, which is REST-based. And it has its own low-level API, which you can access directly without going through the FITMAN CAM software. So if you have FITMAN CAM, you also have the fireware generic enabler repository. So you can start by storing your actual digital assets in the repository, and this means that you will have an URI, or better in this case a URL, pointing to your actual digital assets. Then what you have to do is to virtualize these assets in the asset repository, defining an attribute set which is meant for this. So you will have some standard attributes for your class of assets, where you will have, for example, I don't know exactly what is your application, but let me simplify. You will have an asset with a single property named CAD file, and this property will have a value with the URL pointing to the repository, which is of course there in the same on the same instance.
Yeah, I think I got it.
This of course is just an idea, because if you have any other storage available which is more convenient for you, for example, one alternative of using the repository, which is included in FITMAN CAM, is to use the object storage generic enabler from fireware, which is from the cloud chapter, in fact. But that is in case you will need a distributed storage facility to store very, very large objects there, without worrying about having your system offline, because in fact the object storage has a replicated database in the background. So it is really cloud-based. So if you have more advanced requirements for storage, you can use something like that instead of the repository.
I understand. All right, thank you.